In this video, we'll be going over developmental pathways, but what we are looking at isn't just any ordinary pathway. This is the game of pathways. By the end, only one will sit on the Iron Throne, or in more specific terms, be expressed. Let's take a look at the genes in this pathway. First, we have Cersei Lannister, a diabolical gene that will do anything it takes to be expressed. Next is Jon Snow, king in the north and a gene that is willing to risk everything to protect the living from the next gene, the White Walkers. In this pathway, we also have Daenerys Targaryen, the rightful heir to the Iron Throne and a gene with a title that just keeps getting longer. And finally, we have Daenerys' dragons, a gene that was once thought to be extinct. Let's see how these genes interact within the pathway. The dragons activate Daenerys, giving her much of her power and influence. When functional, Daenerys inhibits Cersei and is able to take control of the throne. The White Walkers inhibit the dragons, as they are able to kill them and recruit them into their undead army. Jon Snow inhibits the White Walkers with his Valyrian steel and stocks of dragonglass. Putting all this information together, we now have a developmental pathway that looks like this. When there are no mutations, Jon inhibits the White Walkers, which allows the dragons to then activate Daenerys. And with Daenerys active, she inhibits Cersei and sits upon the Iron Throne. With the normal pathway established, let's explore some examples of single mutations. What would happen if a mutation removes the dragon gene from the pathway? Without the dragons, Daenerys cannot be activated, which means that Cersei is not inhibited. The Cersei gene will then be expressed and be the ruler of Westeros. What if a mutation removes the White Walkers from the pathway? In this case, there is nothing inhibiting the dragon gene, so Daenerys is activated and Cersei is inhibited. Daenerys will be expressed and sit on the Iron Throne. It is possible to have double mutations, where two genes are removed. Let's say that both the Jon Snow and White Walker gene is removed. What gene product will be expressed? Similarly to the second single mutation example, since there is nothing inhibiting the dragon gene from being expressed, Daenerys is activated and inhibits Cersei, meaning Daenerys will take her rightful place upon the Iron Throne. What happens if both the White Walker gene and dragon gene is removed? In this case, Daenerys is not able to be activated, and therefore will not inhibit Cersei. This leaves the Cersei gene product to be expressed and sit on the Iron Throne. Much like the politics of Westeros, developmental pathways can be complex and filled with intricacies, but it is important to remember, when you play the game of pathways, you transcribe or you die.